This video is going to go through an example of finding the resultant displacement of a vector using vector addition. An airplane flies 250 kilometers at 35 degrees north of east and then changes direction and flies 175 kilometers at 20 degrees west of north. Find the displacement from the starting point to the ending point. First, it is helpful to draw a sketch of the problem. Originally, our airplane is flying at an angle of 35 degrees north of east at 250 kilometers. Let's call this vector A. Then it flies at an angle of 20 degrees west of north for 175 kilometers, which we will call vector B. The resultant vector R travels from the initial point of vector A to the final point of vector B. In order to find the displacement, we need to break each vector up into its x and y components. The resultant x component is equal to the x component from vector A plus the x component from vector B. The resultant y component is equal to the y component from vector A plus the y component from vector B. Let's break down vector A first. The x component of vector A is equal to the magnitude of vector A multiplied by the cosine of the acute angle, which is 35 degrees. Substituting, we will multiply 250 kilometers by the cosine of 35 degrees, which gives us 205 kilometers. Last, we need to look at the direction of the vector to determine the sign. Since vector A points to the right, it is positive, so the x component of vector A, or A sub x, is equal to 205 kilometers. Now we will find A sub y, which is equal to the magnitude of vector A multiplied by the sine of 35 degrees. Substituting, we have 250 kilometers multiplied by the sine of 35 degrees, which gives us 143 kilometers. Now we need to address the sign of vector A. Since it points up, A sub y is a positive 143 kilometers. We will now go through the same process to find the x and y components of vector B. The x component is equal to the magnitude of B multiplied by the cosine of the acute angle between the x-axis and our vector. This means that we need to take 90 degrees and subtract 20 degrees to get the acute angle between the x-axis and vector B. So we will be using a 70-degree angle instead of the 20-degree angle. Substituting, we have 175 kilometers multiplied by the cosine of 70 degrees, which to three significant digits is a magnitude of 60 kilometers. Last, we have to take into account the direction. Since vector B is pointing to the left, B sub x is equal to a negative 60 kilometers. Moving on to the y component, we have the magnitude of B multiplied by the sine of 70 degrees. Substituting, we have 175 kilometers multiplied by the sine of 70 degrees gives us a magnitude of 164 kilometers. Since vector B points up, the y component is a positive 164 kilometers. Now that we have the x and y components of both vectors A and B, we can use vector addition to find the resultant x and y components. The resultant x component can be found by adding A sub x plus B sub x. Substituting in the values for A sub x and B sub x, we have 205 kilometers plus negative 60 kilometers. This gives us 145 kilometers as the x component of our resultant vector. Switching over to the y component, we have A sub y plus B sub y equals our resultant y component. Substituting, we have 143 kilometers plus 164 kilometers equals 307 kilometers for our resultant y component. To find the magnitude of the resultant vector, we can use Pythagorean's theorem and take the square root of the magnitude of r sub x squared plus the magnitude of r sub y squared. Substituting, we have the magnitude of 145 kilometers squared plus the magnitude of 307 kilometers squared. Once we take the square root, we see the magnitude of the resultant vector is 339.5 kilometers. However, our answer should only have three significant digits, so this turns into 340 kilometers. Now that we have the magnitude of the displacement, we need to turn our attention to the direction of the vector. To find the direction, we will use a little trigonometry. We are trying to find the angle between the x-axis and our resultant vector. We know the x and y components of the resultant vector, so we will use those two sides and a little trigonometry to find the missing angle. Since we know both the opposite and the adjacent sides, we will use the tangent function. Specifically, the tangent of angle alpha is equal to the magnitude of the y component divided by the magnitude of the x component. Since we want to find the missing angle, we need to use the inverse tangent function to solve. We will take the inverse tangent of the y component divided by the x component, since the y component is the opposite side and the x component is the adjacent side. Substituting, we have the inverse tangent of 307 kilometers divided by 145 kilometers. This tells us that angle alpha is 64 7/10 of a degree. Thus, our final answer for the displacement of our resultant vector is 340 kilometers at 64 7/10 degrees north of east.